Today we're going to talk about 5.4. We're going to do example 1 from the handout for class. You'll notice that it is a polynomial, 2x cubed minus 3x squared minus 12x plus 1. So we're going to start off with the items that we need to use for the original function. So again, I'm talking about 2x cubed minus 3x squared minus 12x plus 1. Domain here should be all reals, so there's no restrictions. Find my y-intercepts, which means plug in x equals 0. If I plug in x equals 0 here, I should get y equals 1. So remember, that's a point. This should be on my final graph. B, find my x-intercepts. This is important. You're always going to set it equal to 0. So 2x cubed minus 3x squared minus 12x plus 1. You should try to factor it if you can factor it. Quadratic formula if you can. Now this is a cube. We look at it and we can't do it. So there are other methods, but for this class, if it's a cube or it's something that's not factorable, then you're going to go ahead and use your calculator, and remember to use your 0 button. So remember, you're going to graph it in the calculator and use the 0 button. Okay. So the answers from that should be a negative 1.86, comma 0, 0.082, 3.282, comma 0. And it's a cube, so you should expect 3 zeros for that piece when you actually look across it. But again, I always want you to find the x-intercepts by hand if it's possible. If you're not sure on a test, you can always ask me. So these 3 are points that need to be on the graph. So we're essentially right now done with the first function. Now we're going to come back to it. Okay. But I'm going to now go to my first derivative. So that should be 6x squared minus 6x minus 12. And so now I'm going to use everything that I need for my first derivative, which would be my critical values, my increasing, decreasing, and my relative extrema. So critical numbers, remember that's where my first derivative is equal to 0 or where it doesn't exist. In this case, that doesn't apply, so set this equal to 0. I get 6x squared minus 6x minus 12 equals 0. I can pull out a 6. Factor it completely. So I get x equals 2 or x equals negative 1. Remember to always double check, are those in my domain? My domain for this problem was all reals. So those are my critical numbers. That's my answer for C. D said find your increasing and decreasing. So this is where we're going to draw our chart out. We have no restrictions on our domain. So negative 1 and 2. I'm going to plug in again. Remember, we're right now dealing with the first derivative. So plug in a negative 2. We'll plug in a negative 2 to this function, 6x squared minus 6x minus 12. Again, you can use your calculator for that. You should get a positive 24. Plug in 0, we should get a negative 12. Plug in 3, you should get a positive 24. So remember what this means. This means that I'm increasing, I'm decreasing, I'm increasing. So based on that piece as well, I should know that I have a max, relative max here, and a relative min here. So I can answer my questions from here. So D says, where am I increasing? Where am I decreasing? So I am increasing from negative infinity to negative 1. I'm decreasing from negative 1 to 2. And I'm increasing again from 2 to infinity. So that's my answer for D. Remember, when we're trying to find our relative min and maxes, we have to go back to the original function to find the y value. So when you go to the original function and you plug in a -1, and again we're going back to this original function here, 2x cubed minus 3x squared minus 12x plus 1, plug that in, you get a positive 8, plug in 2 into the original function, and you should get -19. So my answer for E, I have a relative maximum of 8 at x equals -1, and I have a relative minimum of -19 at x equals 2. This is what I have here on this chart as well right here. Okay. But they have to be listed again with that piece. Please realize that again, these are 2 points that should be on my graph. Going to my last piece before I go to the final graph is I'm going to be dealing with the second derivative. So we take the second derivative of that first derivative, and I'm just going to rewrite the first derivative so you can see it here on the same screen. So the second derivative, 12x minus 6. So this is what I'm using now. Possible inflection points is where my second derivative is equal to 0 or does not exist. That doesn't apply here. Should get x equals 1/2. That is in the domain. So I'm going to do my chart. And remember, we're using the second derivative right now to determine the concavity. So I can plug in 0 here. Plug in 0, I'll get a -6. Plug in 1 into this piece here. Again, the second derivative, it gives me 12 minus 6, which is 6. So what I just got from that piece is this is concave down, this is concave up. So this is a frown here, and that's up. So this will be an inflection point because I'm shifting and it is in the domain. So to finish that piece, concave down from -infinity to 1/2, concave up from 1/2 to infinity. I need to go back to the original function to find the rest of that inflection point. So I'm going back to the 2x cubed minus 3x squared minus 12x plus 1, and I'm plugging in a 1/2. And again, I would definitely let your calculator do this for you. Just be careful with your parentheses to make sure you put them in correctly. Please practice putting it in your calculator. So we now have an inflection point. Since it's asking for the inflection point, make sure you list it as a point. So that's the answer for F. F was the possible inflection points, and then G and that piece there. So here's my answers for that piece. We're going to now graph every single piece that we have that we've done in here. So we're going to plot our x-intercepts, our y-intercepts, any point that is an actual graph. So this point is on there. Okay, my relative min and maximums better be on there. And if you need extra points, then plot extra points. But those points that you're supposed to find have to be correct on here. So we had a y-intercept at 0, 1. We had a x-intercept at -1.816. We had one very close to 0. And we had one at 3.2. Really close there. We had a maximum, relative maximum, at the point -1.8. And relative maximum, so that's up here. And we have a relative minimum that's way off of the graph at 2, -19. So it's going to be way down here. I do have enough now to actually graph it. Make sure that you are increasing and decreasing where you're supposed to. remember I forgot to plot this inflection point, but that should be a shift from where I'm going down, which was here, right? And right in there, right there, should be where I'm shifting from up to, down to up. And you can see that that, again, went like this. There was a shift there, which is the inflection point. Double check this in your calculator. Make sure you have it right, because again, this is going to be a 20-point problem on there. If you're not sure what you need to show, always can plot extra points.